Okay, 7th grade, this is video 2 of lesson 12.6. We're going to be looking at a couple different formulas with this lesson, but one thing to keep in mind, if we were actually doing this lesson together in class using our scientific calculators, you would not have to have these formulas memorized. I'm not asking you now to have these formulas memorized, but we are going to take a moment to look at the formula to respect where a button on our calculator comes from. So if you have any type of scientific or graphing calculator at home, it would be worth searching up using Google. Try to find a video where it shows you how to get to the button if you can't figure it out on your own, especially on graphing calculators. There's a couple extra steps. Or you can actually Google a permutation and combination calculator, and there's options on there as well. But we're going to go ahead and treat the first part of the definitions as if we had to memorize the formula, just so you can respect where it came from. So what's different with permutations in this video compared to the last video, if we're looking at permutations of a number of objects chosen a specific amount at a time, this is going to require this extra formula. In video 1, we just looked at permutations of objects. But now we're looking at, for example, here, if we have 8 objects and we want to choose 2 of them. Remember, permutations are used when order matters. So anytime we're looking at a specific number of objects, and we want to choose a smaller amount of them at a specific order, we're going to use this here. This is a permutation of n objects chosen r at a time. So this is the notation that you use. They look like little subscripts. Okay, the buttons on your calculators will look like those as well. And the formula is going to be n factorial divided by, and then you're going to do n minus r, that number factorial. So this is what it would look like. If we have 8 objects chosen 2 at a time where order matters, we're going to have 8 factorial divided by 8 minus 2, which is 6 factorial. And one thing that's nice about these is if you have 8 factorial listed out divided by 6 factorial listed out, then a lot of the values actually cancel out and it ends up just being 8 times 7, which is 56. This means you have 8 objects, you want to choose 2 of them and order matters. So we have 56 outcomes that can happen. Okay, so I don't have a scientific calculator, but I can show you on my graphing calculator. The way I would input this is I would just click 8 to represent the total number of objects. Then I'm going to go over and select permutation, chosen 2 at a time, and it does the work for you. Okay. What you might notice though with permutations of n objects chosen r at a time, if you just make this connection that you subtract for the denominator and then cross off what they have in common, it is essentially the counting principle all over again. Okay, so if we look at another example here, got it 3. There are 6 students in a class of 8 desks. How many possible seating arrangements are there? Well, if we're talking seating arrangements, order matters where you put those students. So out of the 8 desks, we're choosing 6 of them. So you can think of it as 8, pick 6, or choose 6, order matters. Or if you think about this formula here, it's just permutations. We have 8. And then on the bottom, we have 8 minus 6, which is 2. So we would end up crossing off the last 2 values. So it would just be a permutation of 8 options for the first desk, 7 options for the second, 6, 5, 4, 3. That's us choosing 6 students with the 8 options we have total. Okay, so whether you have the button or if you want to think of it as a more laid-back permutation, okay, you get the same answer. In class, we would probably stick to the button, but what's nice about permutations, choosing n objects chosen r at a time, is it's just using a basic permutation. 8 options to choose from, 6 of them that we're choosing total. Okay. A note here. Oh, we already talked about it, so we don't need to say this again. Okay, so before we go to combinations, I just want to clarify one last time. If you're dealing with permutations where order matters, whether you're choosing a specific number of objects at a time like we did here, or in the last video where we're just looking at all the possible outcomes, you're really just looking at the counting principle. Okay, but when you're choosing a specific amount of them at a time, you have to take away any options that we don't care about. So again, in this case, we're only choosing the first 6 desks because there's only 6 students, even though there's 8 total. So we have 8, 7, 6, 5, 4, 3 because of 6 students where they can sit. And once you choose a student, you have 1 less student to choose from. Okay, so you can kind of decide, do you want to think of it as the formula or the button on your calculator, or do you want to think of it as a permutation? But with combinations, it's not that straightforward. You have a little bit extra to think about, because with combinations, no regard to order exists. Order does not matter. You're still selecting n objects chosen at R at a time. So like, for example, selecting 2 side dishes from a list of 8 options. Order is not going to matter how you choose those. You can choose a salad and then a steak, or you can choose steak and then a salad. That's not going to make a difference. You're still getting the same order. Okay, so the biggest key when you start solving these and finding these outcomes is, does order matter or not? So here's the formula that you would use if order does not matter. Instead of, you'll notice most of it's the same as permutation, but then we have an additional value in the denominator. Okay, and I explain here in this paragraph why. So if order does not matter, instead of permutation, we're going to use combination, which is going to be a different button on your calculator with a C instead of a P. Okay, and we have 8, choose 2. So notice I stuck with the same 2 numbers as permutation when we had 8, choose 2 permutations. Here we have 8, choose 2 combinations, and we're getting a different answer because order no longer matters. If order doesn't matter, we're going to have a smaller selection of options. That's why we have 28 here. Okay, so anyways, I don't want to get too far ahead. So if we have our formula, we still have our 8 factorial and our 6 factorial from the permutation formula. However, we have an extra 2 factorial. Whatever your R value is also a factor in your denominator. And the reason that exists is you don't want to repeat the 2, even though you have steak and pork and steak. You're eliminating that repeat option. Okay, so if we list all of our numerator, here I listed both factorials of my denominator, and I'm noticing instead of just 8 times 7 in the top, like I did in my permutation, I now have to divide by 2 as well, because that's where that extra piece comes into your formula, because you want to take out the 2 chances of repeating your 2 choices. Okay, so essentially this one's chopped in half to 28. So that's what I do to explain this here. So if you're wanting to think of this more as, okay, I'm just going to memorize this formula since I don't have time to look up all these formula inputs on my calculators using Google. Just remember, it's the same formula, but now you put the R factorial next to it. Okay, so I'll approach it both ways in Got It 4. For Got It 4, we have, in how many different ways can you choose 3 types of flowers for a bouquet from a selection of 15 types of flowers? Order doesn't matter for a bouquet. We just want to choose, of the 15 options, we want to choose 3 of them. So if we use the formula, I kind of condensed it here, thinking of permutation. So I'm going to actually do that 1 second. Here's our input button on our calculator. So 15. My calculator, again, is going to be a little different if you don't have a graphing calculator. We're going to choose the combination button, and we're going to choose 3 of them. 455 is what we should get. If you want to think of it more as a permutation but take away repeats, we have, if we listed out our full formula, we would have 15 all the way down to 1 written down here. So I can even show that for you on this side. So I can do that. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's a rather lengthy one. And then the denominator, we have a 3 factorial, so 3, 2, 1. And then we also have, it would end up being 15 minus 3 because it's n minus r, so we have 12. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if you're literally taking the formula and you're not making the connection to permutations and dividing by repeats, and if you're not taking it as the button itself, it's a little bit lengthy formula, but a lot cancels out once again. And I'm just left with 15 times 14 times 13 over 3 times 2 times 1. Okay, so that's where this idea, if you can make that connection of it's a permutation, we have 15 options, choose 3 of them, no repeats, and then here we're going to take out the repeats. So it just kind of depends. Whatever's most comfortable for you. If this is more comfortable, write it out. If you have a button and you can figure out how to use it, use it. Okay, or you can do, we have 15 options, choose 3 of them, divide by the 3 potential repeats of having them. I mean, it's always going to be dividing by, that smaller number. We'd end up with 455 different ways. So again, whichever option is easier for you, and if me giving you all these options is actually making this worse, make sure you reach out and email me. Let me know if you have a calculator, if you don't, what approach you'd rather take, and then I can try to narrow it down for you. But that wraps up our notes. Okay, so it might be worth taking time just to look on a Google video and find those buttons on your calculator, or search up a permutation and combination calculator online and inputting it. As long as you've at least seen where these 2 formulas come from, you'll have a respect for why they exist, and you truly would have a respect for being able to just push a button. So on your worksheet, the biggest piece of information that I'm going to be looking for is, are you using the correct approach? Are you using just a simple factorial like in video 1? Are you including repeats or not? And then on the back side, I believe it is, of the worksheet, are you using the correct permutation or combination? So that's your biggest takeaway. And of course, if you have questions still, please email me.